Okay, so this is going to be our first flip unit, and we're going to do section 10.2, the parabola. So if I'm going to start off by talking about the definition of a parabola, and you guys should take notes in the box below. So for us, the parabola is going to be this. It is the set of all points that are the same distance, so I'll say same distance from a fixed line, and that line is going to have a special name called the directrix. So D-I-R-E-C-T-R-I-X, the directrix. So I'll highlight that one for you. And I'm going to explain all this stuff in just a second, so bear with me for 1 second. So, definition so far is the set of all points that are the same distance from a fixed line called the directrix to a fixed point called the focus. Okay, so here it is. The set of all points that are the same distance from a fixed line called the directrix to a fixed point called the focus. And that point I'll also highlight for you. So these are the two keywords for us. Okay, so let me go explain what this actually means. So check out this picture over here to the right, okay? Over here to the right, I have a nice picture of a parabola set up, and obviously this blue line here represents the parabola. So here it is right there. That's the parabola. This point right here, this black line, or I mean, sorry, this black point right here, this dot, this is called the focus, okay? And this is the first part of the parabola that we need to talk about. And the focus is going to play a very, very important role of the parabola, but let me just explain what it means in terms of the definition here. So we have this focus here, we have the parabola, and then we have this line over here called the directrix. Here it is right here, D-I-R-E-C-T-R-I-X. And the definition says it's the set of all points that are the same distance from a fixed line, the directrix, and a fixed point called the focus. So here's what they mean. So let's pick any point. I'll change my colors. Let's go to blue. Let's pick any point on the parabola, and we'll call this point, it's some x comma y. I don't know what it is. But if I draw a line from that point to the focus, it is the exact same distance from that point down to the directrix at right angles. So this distance is the same as that distance. And it works for all of them. Look, I'll pick a point way over here. I'll call this like x1 comma y1, whatever it happens to be. And if I draw a line from the focus to that point, it is the exact same distance all the way down to that directrix here. So that distance is the same as that distance. This can really be illustrated well when I show you this little over here on this Desmos thing. I'll make a link to it down below. But watch what happens. So this point in the middle here, that's your focus. This line down here is your directrix. And watch what happens when they start moving around. You can see that as the parabola gets skinnier, both the focal point and the directrix move in sync with each other. So you can see how this is playing out. And if I pause this over here, and we think about any point, I can't really draw on this particular, on Desmos, but let's say I pick a point over here like negative 10.5. If I drew a line from negative 10.5 and I went down to be the exact same distance, any point from here to here, same distance from there to there. So hopefully that makes sense as to what we're talking about here for the parabola. Okay, let's continue and let's label all the parts of the parabola that we need to be responsible for and know. So the first thing that should be familiar to us is that every parabola should have a vertex, and that should be evident, and it can either be the lowest spot on the vertex or the highest spot, just like it was in the last chapter. So it's either high or low. All right. The second thing that we have to talk about is that every parabola is going to have a focus, which is this point over here, and every parabola is going to have a directrix, D-I-R-E-C-T-R-I-X, and that was going to be the line. The directrix is always going to be a line, the focus is always going to be a point. And then we have to define some things about these things. So the distance from the focus to the vertex is going to be defined as A. We're going to call that A units. So that means the distance from the vertex to the directrix has to be negative A units away. And I'm going to do some examples in the module later so you can see. All right? So if the directrix is negative A units away, then that means for this parabola here, the directrix is going to be the equation of the line y equals negative A. So these are all these points that we need to be responsible for. Um, the last thing that every parabola has is something called a lattice point, and the way they spell that is Lattice, a lattice point. So the lattice point is this. If you are a units from the vertex to the focus, if you go perpendicular to a units, that point is guaranteed to be on the parabola. If I go left and right perpendicular to a units, that point, these 2 points are guaranteed to be on the parabola, and they are called your lattice points. So that one and that one right there. Actually, I should draw it better. I should draw this one over here like this. Okay? So the 4 parts that we need to be responsible for are such. I'll highlight them for you. We need to know about the focus, that's inside the parabola. We need to know about the vertex, which is nothing new for us. Something that is new is this thing called the directrix, and it is a line, and it's the line that's equidistant that we talked about before. And then these 2 lattice points here. And again, they are, if this distance is A, then this distance perpendicular to it is 2A, and those are 2 points that are guaranteed to be on the actual parabola. And again, I'll do some examples for you. Okay, for this last little bit here for this lesson, I wanted to tell you that parabolas can open up 4 ways. Parabolas can open up, like in this case. So that means that my parabola is opening upwards. So my focus would be somewhere around here, my directrix would be somewhere around here, and of course my vertex is here. They can open down, and this is nothing new, right? It has to do with that a value in front of that x squared term, and again I'll show you examples. So here's vertex, here's our focus, that means our directrix would have to be somewhere up here, alright? And something new for us is that parabolas can open to the left. Like, this is what it means for a parabola to open to the left. So the focus would be here somewhere, the vertex would be here, and the directrix would be somewhere over there. It'd be a vertical line. Or parabolas can open up to the right. Okay? So the focus would be somewhere over here, the vertex would be here, and then the directrix would be somewhere over there. Okay? So the parabola can open up, I'll just make this a little smaller for you so you can see. A parabola can open up 4 different ways. It can either go up, they can open down, they can open left, and they can open right. And I'm going to show you how to do all those things in the examples down below. So hopefully you're off to a good start.